Hello, this is Project In the Know Fake News Detection. In this video, we will be demoing our application and doing a step-by-step walkthrough of the different components in our application. Let's begin with the user interface of our project. This is the user interface of our project where users can either enter a link, enter text, or upload a file to receive an accuracy score. Let's start by entering a factual article from the New York Times. Our service analyzes this article and classifies it as real, with a 92% confidence. Next, let's try a fake news article which contains little to no verifiable facts. Our service classifies this article as fake with 98% confidence. Next, we will be explaining the server-side implementation of our fake news service.
The web server is written in Python Flask. It's comprised of three major components. We have our error reporting using Sentry, user login using MongoDB, and of course the web application itself. Our initial design involves us containerizing each functionality of the web server, having a different container for the database, having a different container for the pre-processing and model prediction, and having a container for the web server. We discovered this design had a high response rate due to the number of containers that it had to interact with, and we decided to reduce that time by building our what embeddings our startup time, so that when the actual web service is up, then the prediction and the processing can happen a lot faster. So rather than having a Docker Compose file to connect all the containers, we decided to use one Docker file, which had a much lower response time. We also switched from the local MongoDB container into a cloud-based MongoDB and also cloud-based Sentry.
Hello. Preprocessing means extracting meaningful information from data. As part of preprocessing, we perform functions such as standardization, tokenization, and named entity detection. The required libraries for this are NLTK, spaCy, pandas, beautiful soup, and regular expressions. In our process news function, we remove information that doesn't add value to text such as Twitter mentions, email mentions, HTML tags, remove characters other than alphabets. We also remove stop words using NLTK. spaCy can also be used for this. In our named entity detection function, if you send a text, it will identify the entities using spaCy and named entity detection model. For example, if a text contains Adobe, it will be identified as an organization, and if it has a person name such as Hillary Clinton, it will be identified as person. We replaced all such mentions of organizations and persons as alt and name to decrease bias of our model. Here's an instance where we performed reprocessing, and here is our end result. Thank you.
After the pre-processing has been done, the first thing we do is to load all the embeddings from the pre-trained model of Glove, which was developed by Stanford, into memory, so we can get the embeddings at a much faster pace. Split the data set into the train, validate, and test in 70-20-10 ratio, and using the pre-processed embeddings, we build a fully connected neural network of 300 by 128, and we train that over 20 epochs with using the Atom Optimizer and a sigmoid activation function. After 20 epochs, we can see we were able to obtain a training accuracy of 92%, a validation accuracy of approximately 93%, and an evaluation on the test data about 93% as well. Using a threshold of 0.5, we're able to build the confusion matrix and obtain an F1 score of about 94%. Visualization to the training per epoch, as you can see, the validation and training accuracy goes up and tends to flatten out as it should be, and the same thing for the training and loss for the model. For the deployment, we Dockerize everything with this Docker file, which uses Python 3.5 as a base image. 3.5 because that's the most compatible version with TensorFlow. Install all the requirements and dependencies and run the server off port 80. We tagged the image, built it, and uploaded it into the Google Cloud, from which we created 2 virtual machines in a Docker Swarm to run these containers off of. We initialized the number of replicas to about 4, which to make sure it keeps alive at least 4 containers at every time. These are the two virtual machines, and you can see the external IP is 106.38, which you see it's being run out here. So here's the final service. And add a link. We can test this out to see that. It does categorize it as real with a 64% confidence.
To measure the performance of our model, we chose the 4 most commonly used algorithms for fake news classification to compare against. Our performance calculations were done using false positive, true positive, false negative, and true negative values. We found that our neural network model's accuracy, precision, recall, and F1 score were considerably better than the performance of other models using the exact same data. The RC curve and Gini coefficient of our model's results also show the strong performance of our model.